to our Thought Leadership interview series. I'm Vicki Castori, editor of Packaging Technology Today. KUKA's North American Chief Regional Technology Officer, Ed Volsick, is here to discuss palletizing and mobile robotics. Thank you for joining me, Ed.
Thank you so much for having me on your show today. I'm really excited.
It's great to speak with you. So to start, please tell us a little bit about KUKA and your latest innovations.
Sure. So I'm going to start with our AMR portfolio. So KUKA developed an AMR portfolio that meets the needs of our customers and integrators, and really meets the needs of, I would say, manufacturing in general. KUKA AMRs were specifically designed for industrial intralogistics applications, so moving parts, pallets, racks throughout manufacturing plants and warehouses, really in all industries. I would say KUKA took its long history and knowledge in industrial six-axis robots and translated that design philosophy into our mobile robot platform. So we first entered the mobile robot market, I think over 15 years ago now, with our OmniMove platform. And this platform could handle from 3 tons up to over 100 tons and featured our OmniWheel technology, which allowed it to move in all types of directions and crab in all directions. Now, KUKA has introduced a number of products over the last couple of years, including our 600 kilogram payload AMR, which offers end customers with a low profile robot, small enough to maneuver throughout tight spaces. Last year, actually at ProMat, we featured a demonstration with the 600 kilogram AMR moving mixed load pallets in a cell. The cell highlighted what I would say is a typical use for palletization, including mixed load palletizing and depalletizing. Then last year, KUKA introduced what we call our KMP 1500P. This is a 1500 kilogram payload capacity mobile robot, and features a really low profile and uses differential drive technology to move the AMR throughout its motions. So this gives it the ability to have zero turning radius, basically turning on the spot, I should say, and giving it really high maneuverability. And we'll be releasing a 3,000 kilogram payload platform here really soon. And all of these AMRs feature scanners, laser scanners, safety scanners on the front and back, giving it 360 degrees of safety. And it uses LiDAR for mapping and localizing throughout its environment.
Yeah, so
Uh,
what are some of the main operational challenges that this new line can address compared to your past lines?
sure. So I would say similar to general automation, these products really address that dull, dirty, dangerous jobs, right? These are jobs that are difficult to staff for. Manufacturing has faced really a major resource issues over the past years that really were exacerbated by COVID and demographic changes. So you have a large generation of baby boomers right now starting to retire, and a younger generations that are not interested in working manufacturing. So it leads to high turnover rates, and manufacturers find it hard to find labor and move material in plants, including staffing forklift drivers. So mobile robots really easily handle these types of intralogistics applications, moving material throughout a plant and a warehouse. And then I would say another pain point is relying on labor for pallet storage and retrieval. That increases the risk of errors. So manually handling pallets can also lead to damaged pallets in inventory, and that impacts the plant's or warehouse's operations and ultimately its bottom line. And maybe a third point I would think that really can that autonomous mobile robots can help with is forklift traffic. Those pose safety hazards in plants where, because of their size and speeds, and plants have to consider safety to prevent accidents. So mobile robots have these built-in safety systems, which detect obstacles, people, forklifts, and safely stop and wait until traffic clears. So those are really areas which I think mobile robots do a great job inside of plants.
Well, and you mentioned that the profile is significantly smaller. So are there any space or layout constraints that companies need to consider?
Yeah, absolutely. When you take a look at an existing warehouse, layout, the existing infrastructure. You have to take a look at how the AMRs are going to interface with machines, interface with pallets, racks. These low profile autonomous mobile robots that we have in our portfolio are ideally suited for minimizing the amount of interfacing, physical interfacing with that equipment. So it makes them very easy to fit in to applications where you need to move product from one location to another location. Another thing that organizations need to consider is, what type of routes they would like their AMRs to travel through, and determining, how the AMRs will move through the aisles and needed traffic lanes. So it's important to consider how you want material to flow within a plant, getting from one location to another, how they're going to be loaded, how they're going to pick up the loads and move them.
That's interesting because I was reading a bit of your literature about how palletizing technology affects workflow. Are there any other, important considerations that people should understand?
Yeah, when we talk about palletizing, I didn't even really mention it much in the opening, but KUKA has a line of robots which are focused on palletizing. We have a selection, I would say, from 40 kilograms to 1,300 kilograms, with reaches up to about 3.5, a little bit more than 3.5 meters, so almost 12 feet, giving a lot of flexibility to automate all kinds of applications. Um, so when it comes to optimizing the let's say streamlining that workflow, using robots to automate palletizing of boxes, products really helps to create an efficient flow and storage of products on pallets. It also helps to make, let's say, to minimize the mistakes made and damage to products, like I mentioned earlier. And many facilities are trying to install these cells into brownfield facilities, so existing plants. Their space is really limited, so small footprint palletizing solutions help to optimize those space requirements. For example, we have some solutions that are offered by some of our system partners, like Focus, who have a compact cube cell. Um, these cells are really easy to bring into tight areas, and and then they really pay off in the long run for our end customers who need to move product through and palletize product in their warehouses.
Yeah, that raises another question. How flexible are mobile robotics solutions? For instance, like, can they accommodate a variety of package sizes or pallet configurations if an organization changes their product line down the road?
Yeah, absolutely. Mobile robots are very adaptable overall. They can handle, as I mentioned earlier, we have a couple of different mobile platforms handling excuse me, we have a couple of mobile robot platforms handling various payloads. So lighter payloads like 600 kilograms up to 1,500, and then soon 3,000 kilogram payloads. So that gives you the ability to move all kinds of different loads throughout a plant. Our mobile robots also feature cameras integrated into the top of the unit, allowing it to identify the load that it's carrying. And they're also they're also built with safety scanners, as I mentioned, which are used to also map the complete plant. The AMRs use advanced navigation techniques like SLAM, or what we call simultaneous localization and mapping, where they're constantly scanning the area, comparing to a map. It gives it the ability to adapt to changing environments as well. Um, they also can detect obstacles in the way, and depending on the space available, drive around those obstacles. So all of those types of things are examples of how these mobile robots are very flexible and adaptable to changing environments and changing payloads and changing products that need to be moved throughout a facility.
And then are there any other considerations just in terms of integrating robotics into an existing packaging line?
Um, I would say that yes, when integrating mobile robot platforms into a facility, integrators will consider the existing equipment in the plant, the racks being used, how to interface the mobile robots to the existing infrastructure. So for simple pallet load movement, racks are designed to accommodate. Um, to accommodate the loads, and the robots will typically tunnel underneath of it and pick it up, and then in order to move it. Racks are also sometimes designed to be picked up and moved along with the goods on the rack. These are all things that an integrator will review with their customer and find the solution. A good experienced integrator is really important when considering, automation and the movement of materials. They'll typically handle that physical interface points like the racks and pallets that I mentioned, as well as how to engage with existing machinery. They'll also handle what I would call the logical part of it, so interfacing with the customer's manufacturing execution system, or MES, or their warehouse management system. All of that needs to be, fully designed and thought through so that you can have the most efficient use of your AMR in the facility to most efficiently move material throughout a plant.
That's interesting. And then you touched a little bit on safety, when we were speaking earlier. Are there safety measures or regulatory requirements that organizations or their integrators need to really, consider before integrating a new solution?
Yep. So all of our autonomous mobile robots meet the industry standards that are required for robotic systems for mobile platforms. But organizations also need to consider how employees will interact with the automation equipment in general. So again, autonomous mobile robots all meet these safety industry standards and ensure safe operation around people. And then an integrator will typically work with an end customer to perform a risk assessment, where they'll review the plant layout, equipment in the plant, interactions with the automation equipment, including mobile robots. So they'll work closely to identify the safety hazards and risks that exist in the plant, and then determine the mitigations necessary to ensure safe operation overall.
That is one of the top concerns, along with what you mentioned earlier about end user skill sets. Like, what types of skills, technical skills, do the end users need to have to operate the robotics?
Yeah, as I mentioned earlier, KUKA has a line of autonomous mobile robots that is all managed through what we call our fleet management software system, KUKA.AMR Fleet. And that fleet management system features let's say, a no-code programming environment. So it doesn't require any programming to set up, determine where, the routes that the AMRs are going to travel, the pickup point, charging points, and things like that. So it makes for a very easy deployment of the fleet. So from a skills perspective, our software features a very easy to deploy system. Now, when it comes to automating the movement of material in a plant overall, that frees up a plant's labor to move away from those tasks of moving product around and focus on more added value activities. And then training the labor force to handle maintenance of the autonomous mobile robots and any automation equipment in general is important in order to get the most out of their investment, to ensure a long runtime and an efficient use of all of the capital equipment that they have.
This is all so informative. Are there any other insights that you would like to share with our viewers?
Um, as I mentioned, today's autonomous mobile robots and fleet management software makes it very easy for plants to deploy mobile robots for moving materials throughout the plants and warehouses for these intralogistics types of applications. The payback period is relatively short, and efficiencies, they're really immediately realized. This allows manufacturing and storage facilities, warehouses, to get the most out of their plants. At the end of the day, ultimately increasing the profitability of those plants.
Thank you for sharing your expertise, Ed. This has been a very enlightening conversation. I appreciate you taking the time.
No, I'm very happy to do so. Thank you so much as well.
You've been listening to KUKA's Chief Technology Officer, Ed Volcik. You'll find a link to KUKA's website by clicking videos at packagingtechtoday.com. Thank you for watching.